Alright, so this is my presentation on my data mining project, where I am doing spatial mapping of air quality. And in this case, I'm running a predictive model with regards to energy efficiency increasing over time. So, air pollution remains one of the leading environmental health risks in the United States, with regional disparities linked to differences in energy production and policy. So, as states transition toward renewable energy, it's important to quantify how clean energy adoption influences air quality outcomes over time. I'll go through my results now, where first I'll show the data that I used, the techniques, and then the actual post processing and how the predictive model came out. So, I got all my data from the EPA. And I specifically chose the outdoor air quality data set. In terms of the program, the external packages I got were Plotly, Matplotlib, Scikit, TQDM, Pandas, and NumPy, and then a lot of built-in classes to make sure everything works how I want it to. Okay, cool. So the actual technique to do this is I have a CSV. You can see my architecture on the left and the CSV's architecture on the right. And in this project, I go through the CSV and I parse through it to get trends, and I run a linear regression. I also incorporated automatic feature selection for the columns, so I don't have to hard code that in. Which was a big headache. I have two main scripts: the entry point that runs most of everything, and the modeling, which is just a helper class that assists in some of these machine learning things. All right, now for the actual data. I have first the county level AQI. This is the 2025 raw data, so this is not from the model. I generated this using Plotly and the data set that I got. And then here is the state level AQI, also the raw data from 2025. And this is what it looks like. Same thing. Now for the actual predictions, I was only able to run the state because there's not enough data for the county. As you can see, the county... there's definitely some missing counties. This is through reports from the time I got the data set, which is only the January 1st through March 31st is the current public data set that I can look at. So I could not run a county level prediction, but I did run a state level prediction. And as we can see, with a positive increase in energy efficiency, we'll have a also positively correlated increase in air quality, which is expected. Here I also generated some bar graphs here, which show the top 10 states. You can see the one on the left is 2026. That is the I predicted 12 months forward. So you can see that there's definitely some changes, but some things are still similar, right? This is about a year's worth of progress, but some of these states are doing better than others based off of their previous trends. And when given positive energy outlooks, the air quality will improve generally, and that's seen by the model and by your brain. Again, this is the data I used. If you want to run this model, it's pretty cool. You can get it from my GitHub. I have the instructions for use on the README. It will generate all those graphs and maps that you saw earlier, and you can look through the code. Thank you.